Hello everyone, hope you're doing good. Today we're going to look at planes flying on a globe, some of the challenges we would face if the reality we were given were actually true. Okay, and these are some things that you have probably never thought about, and when we start talking about planes on a globe, one of the first things that people do to defend it is say that, well, we are moving with the Earth and that it is a constant speed. These would be true statements. I'm not saying that's not true, okay? But the Earth does some things totally different than just moving in a straight line at a constant speed. Okay, so speed and velocity, two different things. So let's look at how far this Earth is moving every minute. I'm going to break it down to the minute so that it makes a lot of sense of how crazy fast and far we travel every minute. Okay? So in 1 minute, the Earth is said to be exploding outward or upward, you know, the northern hemisphere going that direction, okay, at about 490,000 miles per hour, which, if you break that down, it moves every single minute about this far, right here. The distance of its own diameter, a little over 8,000 miles. So using this line as a reference point, that's how fast we're moving upwards because of that Big Bang that created everything that we know from stardust. Okay, so but it doesn't just go in a straight line. Okay, the Earth actually also moves around the sun. With the heliocentric model, we have to be going around that giant sun, and we move about 1,100 miles within that same minute. So it doesn't just go straight up. It moves about 1/8 of its own diameter this direction. Something like that, okay? So definitely two of its greatest movements are in that spiral motion around the sun, and the sun is also flying through outer space just like a comet, from what we're told, okay? So all of these speeds are super fast. The Earth only spins in that same minute 16 miles at the equator. Not very far at all compared to those other two motions. But when looking at this topic, many people forget about those. They talk about the spin, they talk about the curvature. I personally believe that those speeds alone right there would make life on Earth impossible. They would make water sticking to this ball impossible. But let's not talk about those. Let's just look at the common issues that we have with curvature and spin, because my mind just cannot wrap around those crazy speeds and all the mathematical formulas that would be needed to make it all possible. Okay? So let's just start out looking at the curve, and every hour on a plane, when you're on a plane and you travel for about an hour, most flights are an hour or longer, depending on where you're going from, planes go really fast. They say they're about 550 miles per hour. Well, how far is that? Okay, in an hour, it's 550 miles. That was a trick question. Wanted to see if you guys are paying attention. Okay, but there's a lot of curvature involved, and I use 4 different websites to kind of get a common answer, and all of them were about the same, and all of them were more than 200,000 feet. But to be fair to the globe, I used the smaller number, 200,000 feet, which is around 38 miles of curvature. Quite a bit of curve, okay, for 1 hour. Well, I looked up all sorts of flight school videos to see how in the heck do these guys avoid going into space when they're flying straight and level, or curved and arched. Well, quite simply, all they do is make sure their wings are even with the horizon and the nose of the plane is even with the horizon, and they fly in a straight line, okay? And they end up staying with the Earth. I don't know how. They don't end up in space, but they're also reaching an altitude of about 30,000 feet before they level off. You can feel yourself climbing to that height, and you can feel yourself staying level, and you stay level for quite a while. And if you fly perfectly straight, again, you would end up about 38 miles off the ground, plus the additional 30,000 feet. Okay, so you'd be in the 40s, and when it comes to miles, somewhere in the 40s. But that's not the only issue I have with this. Okay, you have to realize that when you're landing, it takes you from about 30,000 feet to land 15 to 30 minutes. Okay, and again, to be fair to the globe, I'm going to say it takes a half hour to land. Okay, so 30 minutes to land, and that's a drop of 30,000 feet. Okay, so you're only dropping about 5.7 miles in a half hour. To stay level, it's 100,000 feet per half hour, just to stay level. Which of these numbers is bigger? 100,000 or 30,000? I would go with the 100,000. Way larger number, okay? But you don't feel that drop because it doesn't exist. You'll never feel that staying level, curved path because it is not existent. Straight and level is just as it said. You're flying over a plane in a plane. It's not a curved surface like they would have us believe. Okay? I always thought it was, and I always thought I could see it from a plane window, but you can't. You can't see the curve. It is not there at all. So that's just the curvature. And if you go faster, you have to tip the nose down a lot further, because planes, if gravity's just pulling them downward, because they take the magic gravity and say that's what's keeping them level, okay, it would have to pull down on the nose harder than it does the rest of the plane. Otherwise, by the time you got to the other side of the earth, you would be upside down. Okay, so just the curvature alone, quite an issue when flying on a globe. Okay, but the motion of the earth, and this is one thing that blows my mind. If you look at this little merry-go-round these scientists have made, okay, the merry-go-round has a center, or let's look at that like the North Pole or the South Pole, and watch what happens. They're throwing a ball to each other in a straight line, or trying to throw it in a straight line. But watch what happens here. So they're throwing it in a straight line. Everything works great on a stationary flat surface. Throwing it back and forth. Pretend the ball is an airplane flying over the North Pole. Now the Earth is spinning, and look what happens. It's not windy where they're at. The target that they're aiming at is moving out of the way. It's very simple, very provable, can be done over and over in a lab. Trying to prove the globe is a lot harder than I thought it would be, because believe me, I really wanted to keep that globe. I didn't want to get rid of it. Okay, I literally had just bought my son a globe for Christmas, thinking it was a cool present, and he wanted a globe. Kind of ironic that I'm where I'm at now, but this is what happens. Slowing it down so you can see. They're not doing magic tricks. They are throwing the ball in what they are trying to do in a straight line. But it's not as easy as it sounds. You can try this yourself. I believe this is why they got rid of merry-go-rounds on all the playgrounds, not for safety, but because they totally destroy the globe model. And you can do lots of experiments on a merry-go-round, and they show you that as you get closer to the edge of those things, it's a lot harder to stay on. Some of you may be too young to know what it's like to play on a merry-go-round, but when you get on the center of the merry-go-round, that's the safe spot. You go to the outside, you're about to get shot off of there like a slingshot. Okay, so lots of dangers. Merry-go-rounds aren't the safest thing in the world, but they're fun, and they totally destroy the spinning globe model. Okay, so here's my airplane, here's my spinning globe. As you can see, the continents and the islands up here up at the top of the earth are moving much slower than the land masses towards the equator. The equator is moving rather quickly. Okay, and if I was to try to fly from Canada or Alaska down here to Australia, I could fly in a straight line and let the earth do its thing, because the earth is spinning faster, but it would still be challenging trying to land in Australia. Okay, my wife wants to go there. I'm terrified, because what if the globe is correct and we don't make it to Australia? But good thing is, I'm banking on the fact that the earth is stationary and that we can fly from the United States all the way there and not get killed. Okay, so thank goodness we live on a flat stationary plane. Otherwise, our world travels would not be possible. So you people in Australia, you awesome Australians, we'll make it down there to you. And not down there as at the bottom of the world. We're just going to go further south. Okay, so we'll go there one day, make my wife's dreams come true, but definitely not flying to the bottom of the earth to get out of a plane that is landing on much faster ground. Okay, so lots of crazy things when you look into this globe model that don't make sense. Plane flight is one of them. I'm really hoping we can all agree on some facts. And like I say, the most common counter argument you run into is that you can throw something up in the air when you're on a plane and it doesn't smack the back of the plane. That is perfectly true. But if you were to put, after watching the movements of Earth, Okay, 3 different directions your body is moving all at the same time. We're not moving in a straight line, given the model that we have. Okay, if I were to throw up a ball on a car that is going in circles, okay, while flying upwards, if it was a flying car, like the Earth is said to be moving, that ball would move in really weird directions. Okay, it's impossible. You can fly a drone in a vehicle that's moving at a constant speed in a straight line, but if that vehicle goes around a curve, okay, you are going to lose that drone. It's going to smack the walls. Okay, so lots of experiments you can do to try to prove the globe. They're all going to fail, especially when it comes to flying a plane or a drone or just levitating a balloon as high as you want. They're always going to come down. Even the balloons that go to space, they come back down, and they are rather close to where they took off from when the Earth should have spun underneath them. Okay, so some cool things to think about. I know I may have gotten some of the math wrong. I'm not a math person, so you guys can correct me. It's okay to be wrong. Okay, try your own experiments. Try to do things. Don't worry about being wrong and looking stupid. It's okay. That's how you learn. Okay, so if I made a mistake, call me out in the comments. That's okay. I still love you guys. God still loves you. You're still an awesome creation. You're not here to be divided about stupid scientific arguments. The shape of the Earth and the movement of the Earth is not that important, even though we wouldn't be here if the Earth was moving like they say it is. But you guys are awesome. I love you guys. I thank you all for coming here. I really do think that, you know, one of the miracles that God has done recently is send a bunch of people this direction, and it was something that I asked for, and I really hope you guys stick around, because some of the lessons we're about to teach you go beyond this whole Earth argument, and they're really, really important. Okay, so stay tuned for some more. Hopefully we can clarify some things that have made things really confusing for you, such as who God is and some of the things that people have said about him that aren't true, that make it really confusing when trying to have a relationship with the Creator. Okay, so look forward to that. Hopefully we can answer a lot of questions, and you guys can have some clarity, some peace of mind, and be awesome like you really are and like you were intended to be and created to be. Okay, so love you guys. Can't say that enough. You guys are really, really awesome. Even the ones that come here to hate us, we still love you. You're still awesome too. Okay, so take care of yourselves. Hope you and your families are doing good. As always, God bless.